Hello, everybody. I'm the first opening speakers for the day, so supposed to warm you up a little bit. So I saw that you are all already ready for networking, so that's great. Um, uh, Really excited to talk about you about building reliable AI products in banking. And I actually want to start with a question. Show of hands, how many of you knew that you will be here today a month ago? Okay, so here are our planners. Perfect. How many of you didn't know you will be here a week ago? Okay, so here are our open-minded, flexible people that are able to adjust to the environment around them and just go with the flow. Perfect. This is actually pretty important for AI reliability, being able to balance the two, the planner and the open-minded, flexible person. So who am I, and why do you have to listen to me? Thank you for the warm introduction. So as you've heard, my name is Olga. I work as a Director of Strategic Analytics and Data Science at Royal Bank of Canada. Prior to that, I was at Google. Prior to that, I worked at Slalom. And outside of that, I worked with governmental and non-governmental organizations such as United Nations Environment Program, World Resources Institute, and also prominent Canadian nonprofits, Rainbow Railroad and War Child Canada. So it's been 10 years that I've been on this journey, and you may think to yourself, oh, 10 years, that's not a lot. I've been at this longer. I know, me too. But everything that we did more than 10 years ago is pretty much an old stuff that we don't do today, if you would agree with me. And that's why I always put 10 years, because we all have to reinvent ourselves in this field. 10 years or maybe 2 years, you decided for yourself. So I'm happy to share with you some of the things that I learned the way across through my journey in this. So the agenda for today, we are not going to be talking about the data science models and how they work. We're not going to talk about the exciting stuff that comes into the machine learning, the models, the algorithms, the math and stats, and all of it can make a really magical, sometimes, experience for the users. We are going to talk about how to make machine learning work for your organization and the processes and the systems that surround machine learning that make the magical possible. So we will talk about what is AI reliability, what is a machine learning process. I'll take you through some of the use cases that I've seen many, many times repeated over and over again in my past. And we'll talk about problems and solutions to AI reliability. So I'm a big believer that data science, machine learning, and AI are changing banking, and they're changing how our society operates in general at an accelerated rate. And there is a lot of hype about those words, AI and ML, and you hear things, sometimes you agree with them, sometimes you don't. But one thing is certain, that companies are excited about it and they want to take advantage of it, but they're also a little bit hesitant. We've all seen laughable examples of AI when it does something, sometimes cute, sometimes funny, that we expect but we don't understand. So this is an example, a recent example of a Tesla computer looking at the horse carriage and not understanding that it's a horse carriage, but it's thinking that it's a truck. So you may smile, you may have seen this example, but do you want something like this to your project, to what you're working on? Probably not. So the thing here to think about is how to avoid that. And although the companies want and really looking to jump on the wagon of AI, or they want to lead the way and be ahead of others, they're also hesitant to what unreliable AI can mean to their brand and mean to their bottom line. But not to worry, that's why we're here today, and that's why we're talking about it. So what is reliable AI? Building a reliable AI product means being able to foresee when the ML system will fail or deteriorate, and also being able to address. So it's about being prepared. It's about being preventable. It's about looking forward to things that happen, as opposed to fighting things that already happen, or firefighting. There are many benefits to reliable AI that include lower cost, lower downtimes, better adoption from the users, and most importantly, and sometimes overlooked, is the increase to the lifespan of your product or your AI project. If you've invested a lot of effort and time into it, you do want it to last a good amount of time, and you don't want it to fail. So when you think about it, what is the key word here? And the key concept here is failure. So I've spent a lot of time thinking about failure and thinking why did the things that I'm trying to troubleshoot happened. And at the core of the failure, to me, what it is a few errors that happened often. So a few errors in judgment that we all make. Oh, I didn't think this would be a problem. I didn't think this could happen. So the word failure is a word that I want you to remember. We will go back to it in our discussion today. So preventable failures and thinking about it, thinking about how you can avoid them. So if you've been at this for a while, and judging from how serious you all look today, you probably have, you can resonate to something like this. I'm firefighting, I'm waking up to alerts and emails about things that I didn't know will happen today, and yet I have to deal with them. I'm troubleshooting, I'm managing, I'm communicating up and down of why things happened and what we will do about them. So this is a mode that I've seen a lot. I've been there. And you often hear things like, oh, if it's the company, or it's a company policy. Oh, only if the infrastructure was X and Y, if data scientists did this and that, or the engineers did this and that, or if we could have a different software, or maybe next generation thing. So it's important to learn and continue evolving, but it's also important to realize that sometimes some of those things that happen to us are not the result of having the wrong infrastructure, or the wrong software, or the wrong engineers, or the data scientists that aren't just doing their job. It's about our personal philosophy. It's about what we have, because all those things that I've just listed, the company policy, the infrastructure, software, packages, data scientists, your team, your project, that's all you have. That's all you have to work with. And if you blame things on it, then you really have nothing. So it's about change in philosophy, and that's really what I want to focus on today. So I will be walking through a few examples, but I wanted to start with the ML lifecycle. You've probably seen a picture like this or a similar to it before. We have the data collection, data management, training machine learning pipelines, building the products, sometimes the systems that it passes the output to, sometimes the UI that users interact with, quality prevention, and setting up those KPIs that we know the product is successful, launching it and then monitoring it, and going through this cycle again and again. So I want you to think about this cycle that you've probably seen 100 times or more, and think, where does reliable AI come in here? When do I think about reliable AI? So if you, any thoughts, just shout it out.
Every step.
Everywhere, exactly, every step. That is correct. So let's look at a few examples. So the first one here, and I'm just going to go through them with you really quick. Credit risk executive notices a decline in overall number of approved loans. And she makes a quick call to the people that she knows are in charge. And here's that the ML system performs as expected. There are no errors, no issues. Everything is good. Just wait for it and it will go back to normal. This is a glitch. So days later, she goes back to it and she finds a sharp decline now in loans. Now, this is a problem. So she calls for a meeting and she says, we need to fix this. So what is causing it? And if you've been at this for a while, an executive is calling you, this is not the place where you want to be. And she sets up a meeting. It's always a big meeting, isn't it? Let's brainstorm where things went wrong. You have to go and make sure that the stuff that you are in charge of is doing all right and nothing is causing an issue. So one thing to know about this case study is that the system is not accepting information from a trained financial professional. The user fills out a form, it's passed to an AI, it analyzes it and spits out approve or decline in seconds, right? So when you're working with a system like that, you have to really look at the AI. So they go and look at the AI, and with risk models, because there are regulations on how they work, it is possible to go through it step by step. We don't always have that luxury, but we can. So we look through this and we find, okay, here is an event coming in. It getting declined. What happened? Well, there was not enough information about the client. Okay, next event comes in. What happened? Decline. Why? Well, not enough information about the client. So where's the information about the client? The same, another one and another one. Where did this information go? Well, what turns out, all the pipelines are running, the information is coming in, but it's coming in as blank. So we are processing it and giving out the decline after decline after decline for a portion of our system. So you may think, well, I know how to fix this. I know how to prevent this, but you've probably, this might have happened to you before. And if it haven't happened to you before, it might happen in the future. So think about the ML life cycle. Where was the error in judgment here? At what stage? So the data ingestion, right? The data is coming in, and it's not what the model is expecting, so it's giving a decline. So the systems like the great systems that we build can fail for a simple reason like that. So what can we do? We can set up checks. We can set up checks to make sure that the data is coming in. It's coming in. It's the latest data that we need. And it is in a way that the model can accept and work with. It's a good thing to check that the infrastructure is also working as expected. So next case study. 2 years ago, a department had hired a third-party service provider to build a cutting-edge AI product. The project went well. He got a lot of recognition for it, and the models were built in a short time within a reasonable budget. So it made a good difference to their bottom line, and so it was a great project. Now, a recent report, so remember, this was 2 years ago. Now, a recent report is showing that the recommendations are rejected by the customers more and more frequently. So the call center agent, the call is coming in, they pick up the phone. As soon as the customer starts talking, the model starts listening to what they're talking about and pumping out recommendation of what might be the problem, what solution could be, and what we could also sell to the customer. Now, if the call center agents don't want to recommend this to the client anymore because the client they feel are not likely to respond, they probably won't do it. So you have a system that is being there, that is operating, but nobody is using it. So that's not good. So what could be causing it? Why are we having this issue? It is not uncommon to see, and it happens a lot in the organizations, that you hire a third-party company, a contractor, or a brilliant intern. They come in, they build an amazing system, they do a handoff. And during the handoff, they explain how to run this, how to operate it, but not necessarily, things aren't always put in place on how to improve it, how to continue to take care of it. The world evolves, products evolve, the company, customers change, customer needs change. So because of that, every AI product, even a great AI product, maybe pump out results that are no longer relevant anymore. So where is this in the life cycle? It's in a training. You do need to retrain, maintain, and upgrade your AI product as it goes. Once it's built, that's not the end. That's just the beginning, right? So the next use case. Product owner gets feedback from users that the classifier didn't flag as many transactions as it used to. So engineering team finds that there is some kind of issue with the data, but it's not a very obvious issue. So there might be something in there, but they're not sure. So she believes that it's important and goes and talks to her data provider. And she finds out that the data definitions have changed. So think to yourself, do you work with third-party data? How often do you look at what they are doing there? Do you have any understanding of how they are collecting this information, or have they changed any of the data definitions? And is it part of your pipeline? And it doesn't have to be external data, internal data as well. Working with other teams that are providing data to you, are they planning any system upgrades? So the way they collect the information would be completely different. You need to be aware of that. You need to be flexible with your model so they can be easily maintained and adjusted to make sure that you can work with it and it doesn't cause you a serious failure every time somebody changes something or migrates. So where is this in the life cycle? Well, it's a data management. How often have you seen architectures when you go from data ingestion into machine learning, data just going in, and everything is great? Maybe some pre-processing on that diagram, maybe a little bit of formatting and data manipulations that are happening, but there is more to data management, and that includes the definitions, and that includes the things that are sometimes beyond of our control. So this one is also a little bit on the communications, because you do need to make sure that you communicate to everybody and you're prepared. And that is not always part of the pipeline, but it's an important routine that needs to be followed. So we talked about some of those use cases, and those are all real use cases that happened to real people that did an amazing job, but we're called up to solve the issues. And maybe some of those issues are happening right now to you, because I see some of you are on your computers trying to work through something. So all of those are preventable, and you can work with them. So, okay. So typical reliability challenges that we talked about today. So a lot of them are in data. It's not actually about ML, because at the core of every AI product is data. And lack of data, lack of appropriately modeled data, shifts in the data or missing data, those are some of the things that can fail an amazing AI product really, really quickly after it went into production. And those are things that are really preventable. There are also ML and engineering challenges. Sometimes we have models that are put to use in a wrong way, not the way that they were designed to be used, creative approaches, incorrect model configurations, or insufficient, very loosely designed models, the incorrect pipeline configuration, the wrong order of steps, for example, when the model is executed something before, while it was supposed to execute something else before that. System challenges, those are the big ones. Shortage of resources, hardware failures, server is down. We've all seen that. API is down. And how do we deal with that? When we build a product, we sometimes assume that things will be perfect, but the real world is not perfect. So we need to think about those. Distributed system failures, releases of the new software and migrations that we sometimes may not be aware of, but once they happen, we immediately realize because there is a deterioration to how the model is running. And last but not the least is the organizational challenges, the lack of resources. We didn't have time, we didn't have the money, we didn't have enough people, or we didn't have the right skills, etc. And very important one that I put at the end there is the communication. So one thing that I want to go to next is the solutions. So how do we prepare for model failures? Well, we could set up raw total checks. This is very simple. I'm sure you could do this, but how often is it actually done? Not so often. Schema changes and data type checks. Do you only find out about those when you have job fails? Or do you have the ability to foresee those and deal with them before they happen? And you could implement that. Data distribution and cardinality monitoring, other trends in your data, other shifts in your data that are causing your models to perform differently because they were not prepared for those shifts. As years after you have launched your product in production, these things are going to happen. So you need to be aware of them happening before it actually becomes your reality and you have to deal with it. You have to go get the money and go get the people and start working on this before the AI product is completely done. Looking at the data updates, if you're working with patch data, are we working with the latest data? Did we load the latest data, or maybe we think we loaded the latest data, but it's actually not the latest? If you're working with streaming data, are we getting it at the rate that we expected it to come? Is the rate changing? Why is it changing? How we're going to deal with it? Do we have a system in place to shut it down if it's not the right one? And communication in place so our users are aware. Monitor data processing. This is something that we have a lot of tools now that help us do that, so we don't even need to worry about it. So do you have the tools or do you have the processes to do that? Model performance under the ML engineering challenges. You can start with your simple ones. What is the model accuracy? What is the precision and recall? We all know that, but are we looking at it consistently over time? Or have we only looked at it when we tried to sell our business partner on the model? So continue monitoring it and setting up the KPIs around it and looking at them is important. Getting a flag that something isn't right automatically is important. You don't need to wait for your business users, your end users or executive to call you to let you know that something isn't right. Okay, so monitoring the model serving. Lots of tools that do that as well. Model results checks. Don't rely on your end users to see if the output of your model is okay. If the product looks all right, set up the systems that are in place to do that. And that is usually very specific to your AI product. So you need to get creative on how you're looking at it over time. 2 years down the road, what is going to look like, and how do we know that it's time to modify, change, retrain, or take it down. System challenges, which we talked about it, timeouts. A lot of times what happens, we've released a new version of the AI product, and all of a sudden it takes much longer to run because we've done some amazing new innovations. And so the timeouts happen, nothing runs, and the system is down, or the system is not in a place where it's supposed to be. So looking after the resources and schedulers, looking after the things on a distributed system to make sure one AI project isn't stealing the resources from another AI project and things like that. Those all can be set up and put in place automatically so you don't have to think about them day to day. Any kind of code environment on change and updates create issues. So we all know that this is bound to happen, and somehow we are unprepared when they do happen. And organizational challenges. So resourcing plans and talent development and putting that into place. Think of it as an investment into everything else I just talked about. This is really not a nice to have these days. For some of the professions out there, it might be not as important, but for data science in a field, fast-pacing field that we are, every 2 years we reinvent ourselves. Every 10 years it's a completely new field. You do need to make sure that your team gets enough time and opportunities for development. And the communication plans. Are you communicating only to your end users? What about your downstream systems that are feeding from your data and your results? What about your upstreams? Are you hearing enough from them what they are changing so that your things don't fail? You do have to prepare those communications, especially to end users. So you don't have to be the person in front of the mic talking to the media about why the company failed to deliver. You prepare that communication ahead of time so somebody else can go on stage and talk in front of the mic. So don't be that person who is trying to fight the fire and talks to the users at the same time. So I'm going to wrap up here. And what I want to leave you with, so I told you my short definition of failure, which is a few errors in judgment happening frequently. Now, let me tell you my definition of success. A few simple routines and practices that we can do often and frequently. And those routines are summarized here. This is not an exhaustive list by any means, but those are the routines that you can take away from today. So you look at them and you smile. I see a lot of you smiling, especially if you've been at this for a while, and me too. Those are simple, but you know what else is simple? Not to do this, right? Your doctor tells you, you should exercise. You should make your exercise routine, exercise 3 times a week. That is simple. But what else is simple? Not to exercise. Make sure you have a drink 3 times a week. Make sure that you have a dessert after every meal. Things like that, right? We do this to ourselves and set us on a path to that road where we are now in trouble. Now, this is serious because it can be it can make a huge impact to your project, your team, the trust of your users, their adoption of your product, your company overall. There is a huge cost to your career and your overall success. So you can avoid that by following the simple routines, thinking ahead of time, preparing yourself for the person you will be 2-3 years down the road when this is live, and not thinking I will hand this off and do something else, and setting up the rest of the people that will be there with this organization even after you leave for success. So that's what I'm going to leave you with, the simple routines. And you don't have to be the same person you walked in today. If you are firefighters that I described earlier, jumping from one issue to another, you can change that. You can become more proactive and use those routines to walk out from the talk today a different person. So I will end here. Thank you very much.